All right, let's do question number 9. So question number 9 says, Jim wants to read 7 books apparently titled A, B, C, D, E, F, and G. Wonder what genre they are. During the summer months. The order of reading these books is determined by random selection. So he's just covering his eyes, reaching for the bookshelf, and pulling off one of these books. Find the probability that Jim will read book C first, book A next to last, and book E last. So there are some restrictions here. So we want the probability of this, let's just call it the desired order. And remember, that's what we want divided by how many possibilities there are in general. So put my fraction bar here. Let's talk about the bottom first. That's far easier. There's A, B, C, D, E, F, and G. So there's 7 books, right? Well, if I'm picking the order that I'm reading them in, that's a sort of way I'm arranging them, right? Whether I'm picking them and then reading them or I'm just stacking them, same idea. So how many ways can I arrange 7 things? Well, that's what 7 factorial would be. Remember, factorial is all about how many ways can I arrange whatever amount of things. So how many ways can I arrange 7 things? 7 factorial. That's our bottom. That's the total number of ways I can arrange it. On top, we're looking for this specific order and how many ways it could happen. So there's 7 possibilities. So we're going to have 7 slots here. 1, 2, 3, 4, 5, 6, 7. Okay, so I don't need that one. All right, so they want him to read book C first. Okay, so he's reading book C first. So how many choices are there in the first book reading position? Well, only one, right? We're only interested where he picks that book. No choices. Okay, so 1 choice there, book C. Now notice there's only 6 left at this point because one of them's already been assigned a position. So if we go on from here, he wants to read book A next to last. Okay, so here's last, next to last. So he's reading book A, and again, there's no choice here. He's reading that book right there. One option. Okay, there's only 5 books left now, right? And then it says book E last. Okay, there we go. Book E goes right here. And there's only one option. Again, we're saying that book E is read at the end. Period. Okay, well, we had 7 choices of book. We placed 3 of them, so there's 4 left, right? 7 choices, take away 4. I'm sorry, take away 3. We get 4 factorial. But you can get that because all that's left is these 4 books. 4 times 3 times 2 times 1. So this whole probability comes out to be 4 factorial over 7 factorial. So if we put this in the calculator, I would use parentheses just to be safe. So open parentheses, 4, hit the math button, it's right below the green one. Go over to the probability menu. The factorial symbol is option number 4, so I'll hit 4. So now I have open parentheses 4 factorial. I'll close those parentheses, hit divide, open a new set of parentheses, 7, hit the math button, go to the probability menu, select factorial, option number 4, close my parentheses, and finally hit enter. Now it's going to spit out a decimal. In probabilities, they want these as fractions, so I'll hit math. It's already on fraction by default, so hit enter. Hit enter again. And you should get 1 over 210. Now, because these numbers are pretty small, you could do this fairly easily by hand. If you wanted to, here's what you would do. The bottom, 7 factorial, can be written as 7 times 6 times 5. And now I'm going to write this as 4 factorial, right? 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 7 factorial. Then on top, I've got 4 factorial. And now, whenever anything's over itself, it just cancels off in a fraction. So that's gone. You've got just 1 over 6 times 5 is 30. And just think of it like 7 times 3 would be 21. So 7 times 30, 210. Whether you do it by calculator or by hand, you have a 1 in 210 chance of reading those books in that order if you're doing it randomly. And that is question 9.